All right, so I'm Ethan Kinney. This session is bringing CAD models into VR. A little bit about myself. I've been using Solidworks now for about 8 years, 9 years. I'm a self-taught programmer, no real formal education in that. I work for a company that does linear motion. I'm the CAD administrator for them. I do a lot of programming for them, macro programming, automating SolidWorks, that sort of thing. Just to let you know, I'm not an expert in VR. Pretty much everything you're going to see today is what I've been able to find on Google, on YouTube, things of that nature. Aside from the headset, I haven't really gone out and spent any money on this. It's using free software, free knowledge out there. I'm not really an expert in programming either. I am self-taught, and so pretty much everything that you see here is what I figured out from Google. But I do find VR very interesting. It's very fun. It's pretty much the bleeding edge of technology. All right, so you might be asking why? Why would you want to bring your CAD models into VR? I hear this a lot. VR is just for gaming. And okay, that's true. Gaming is pushing VR really hard. A lot of the graphics cards that you've seen coming out for the laptops, for the desktops, they're being pushed heavily by gaming. And most of the programs out there for VR are games. I mean, you've got space simulators, you've got job simulators, flight simulators, bomb defusal simulators. That one's actually my favorite game. You are in a room with a bomb and you have a bunch of people around you with bomb defusal manuals trying to tell you what to do, what wires to cut, what wires not to cut. There's a timer going off and everything. It's a great team building exercise, unless you want the person to blow up. So here's some stats on VR. These are projections. More or less, they were expecting 2016 to be the year of VR. It didn't quite turn out to be that way. Mostly, I think, because of the cost of VR, it's still a little bit prohibitive. But they are expecting 2017 for it to pretty much double, and in 2018 to double beyond that. But it can be a whole lot more than just gaming. You can do architectural walkthroughs. You can do remote technical training. I don't know if any of you out there are DIY repairers, but if you have to do auto repair, think about looking up a VR tutorial on how to fix your car, being able to see every part in there, everything exploded, figure out exactly what you need to do to fix it. You can do industrial design review. You can do e-commerce, and actually eBay is already working on this. They're using Google Cardboard and just 360 viewers for their software. Or you could just use it as an engineering utility. See what your machines are doing, see what your facility is like, things of that nature. So pretty much, can you use VR? If you can answer yes to any of these questions, I would say go ahead and try VR. So how many times have you thought, that's not how I thought it would look after the design's all said and done, after it gets built and you get shown? Or have you ever lost a bid because you can't convince the customer, yeah, you need to go with the design? Or have you ever missed deadlines because last minute your boss walks in and says, we need to change this and do a major overhaul, whereas you could have shown him the design really early on in the stage and everything would have changed then as opposed to late in the game? Or if you ever lose perspective on just how your product's going to get built, how it's going to be put together, things of that nature. All right, so I'm going to go ahead and show you guys a demo. It's going to take about 10-15 minutes, and this is all stuff that I've built or slapped together. So I'm going to show you an architectural walkthrough, an industrial design fly-through, and a small product showcase. And for this setup, I'm going to be using a GoBox MXL VR. I'm going to be using an Oculus Rift with the Oculus Remote, and also a Leap Motion controller, which will allow me to do hand tracking. The software I'm using, aside from SolidWorks and SolidWorks Visualize, I'm using Unity, the Oculus Development Kit, and the Leap Motion Development Kit. So let's go ahead and try this out. Helps if I start up the software, though. All right, can you guys see the stuff on the screen? Can you see my hands? Okay, I can kind of see you guys too, so that works. This device on the front is actually doing the hand tracking. It's sending out infrared lights, and the algorithm's pretty smart. It can figure out the hands and all that, and even the gestures and stuff that I'm doing. So, all right, and that's the Leap Motion device. So let's go ahead and do the architectural walkthrough. What you see right here, this is actually my basement. We're working on doing a remodel at my house right now. I've actually got it set up to where I can walk through it, take a look. And this was all done in Solidworks and exported out. You can see I've got my utilities and stuff right there. I'm going to be putting a bathroom back in that area. That's actually where my office is. That's where I did this demo and set it all up. Got a spare bedroom over there, storage room there. But it's all been done in Solidworks and just exported out. I actually got a few other houses and stuff I can look at over here. I'll try and go a little bit slower so I don't give anybody motion sickness. So in here, this is actually a model I downloaded off of Google SketchUp. But you can see you've got some paintings on the wall there. If I come into the bedroom, you can see this user is obviously a Mac user, so we're going to just go ahead and leave this house. Now, one thing you noticed over here with my basement and with this is if I run into the wall, it stops me. The colliders have been turned on in that case. But now this one was imported in, and I think it was also done in Google SketchUp. But I can actually walk right through the walls on this because there's no colliders. And I'll go ahead and talk about that a little bit later. If I come over here, here's just another apartment. Come in here, I'm on the dining room table. You can see the kitchen, all that over there. You can see the bowl of fruit, everything. And you can really walk around and see. So if you're trying to, if your industry is in architecture, you want to show somebody a new design, a new floor plan, this would be a great demo to show. You can really get them up close and personal. They can see the things and go, I don't really like that furniture. I don't like that design, that color, things of that nature. So what I'm going to do is go ahead and switch over to my industrial walkthrough, or industrial fly-through, I should say. All right, so for this one, my former employer, I used to work in the paper industry, or the paper machine industry, and so this is one of our coder machines. I can actually fly around and see the detail on this, all that sort of stuff. This is actually a de-featured model from SolidWorks brought into Visualize and exported out into the software that I'm using to do this demo. But what I can actually do is fly all around, get an aerial view of everything. Over here I have a Mack truck. I think I found this off of CAD. An excavator over here. You can really fly around, get up and close and personal and see all the different details, things of that nature. Over here, military applications, of course. And now in this building, this took a while to download, but it's an entire just piping and heating layouts, and can really get close and personal, see everything that's going on over here, see all the valves, see the text on the valves, fly around it. So if you're trying to show a potential client, a potential customer, what you want to do, your design, something like this, this would be a great demo. You put it in, especially if it's going to be a multi-million, multi-billion-dollar contract or something like that. It's a quick way just to sell your design, sell your ideas, and make sure you don't make any mistakes. Now, for my company, we actually do smaller designs. And so for us, we would be much more used to using something like this, where you can actually see, in this case, I've got a box computer rotating around, a few more things like that. But with this, I can actually walk forward. Let's see if I can find one. I know we were talking about guitars earlier today, so I got one in there. But I can reach out my arms and actually pick it up, start to move it around, things of that nature. I can resize it, scale it, move it around. I could act like I was actually playing it if I want to, things of that nature. But it's an easy way that you could give your customers or your clients a way to play around it, see it, or if you're designing in SolidWorks so you could build it, get up and close and personal, showcase it to somebody else. If you have the platform set up, you could certainly do multiplayer in here, so to say. And if I go to another one, we actually do actuators. So for my demo here, I went ahead and grabbed one of our actuators, gave it some motion, so I could actually showcase what it does. In fact, I could move it around, get it really nice and big, and of course, it's a little hard to control sometimes. But if I wanted, I could go inside and see it moving back and forth and get a little terrified as it moves forward, things like that. All right, so one of the other demos I did, and this is actually something that we're working on at my company, it's just a way to have a store that a client can walk through, see products on the shelf, see products on display, things like that. Like I said, we're in the linear motion industry, so I've got some bearings and some pillow blocks over here, but we're also in the 3D printer industry. So I went ahead and threw in a 3D printer here, and over time it just builds up the model and it changes, builds up another model. Certainly if I spent more time, I could show the actuators moving back and forth, up and down, things of that nature. Here we've just got one of our prints, things like that. So it's really versatile. You could really do a lot of things with it. And like I said, aside from Solidworks, aside from the headset, the laptop, I'm using free software, so it's not that expensive. Here I've got a shooter game. If you guys want to try that later, I suggest you stop by the booth. And this one is just a freehand drawing game where you can use your fingers and draw around. So that's the demo. Of course, my glasses are all foggy now, a little bit warm. All right. And close out of that. Don't need the backup video. That's nice. All right. So for that scene, I actually had about 6 scenes. Actually 7 scenes. I added one of them later on. But each scene had its own environment, its own interactivity, its own models in it. You can really build however you want. If you're showing a customer one thing, you can target it towards their culture, towards their ideals, towards their colors, whatever they may be, and really try and get a better immersive, get them to have an emotional connection with your product, and it can help you sell it that way. The character that I was using, it was actually the same character in every demo that I showed, but it had different modes in it. In the first demo that I showed, it's a fixed mode, or actually that was the intro screen, to where I could move around like this, and it tracks the head movement and all that, but I can't move around, I can't walk around, it's just fixed in place. The first actual demo that I showed for the architectural walkthrough, you can walk around. If there's colliders, you'll actually run into something. And that's something I had to learn. When you're exporting your Solidworks model and you're bringing it into some of these engines to build VR demos, you have to add colliders if you actually want that interactivity, if you don't want them to walk through a wall or peek through a wall, things of that nature. And for the industrial fly-through, it was literally that. You could fly around, you could move around, all of that stuff. You could fly right through buildings if you wanted to, right through things, look inside whatever product you're trying to show, things of that nature. So like I was saying, the character has a collider with it, but your imported models need to have the colliders added in order to have that functionality. Now, the Leap Motion controller I was using, like I said, it projects out infrared lights, and it has quite a few functions for grabbing the gestures, things of that nature. Make it less dependent on a controller so you can actually interact with your environment and make it more immersive. All right, so what do you need to actually do VR? So first, we'll talk about the headset. There are some expensive, professional quality ones out there, but for me, I'm on a budget. I can't really afford those $10,000 machines. So instead, you could get an Oculus Rift, but if you want to avoid a company that's in litigation right now, you could also do the HTC Vive, the Sony PlayStation, any of those headsets, or you can do a 360 viewer. Now, the difference between a 360 viewer and virtual reality, while you can look around in both of them, look up and down, and it'll track that, the 360 viewers will not get your actual head placement. There's no sensor, but I assume as the phones get more advanced, eventually they may have that capability. But certainly the cost there is far cheaper. Google Cardboard is $5, should work with most of your existing phones. You could get the Google Daydream VR. That's pretty good. It's about $100. Same thing for the Galaxy Gear VR. That's about $100. Or you can go on to the other spectrum and you can do augmented reality. Now, the difference between augmented and virtual is in augmented reality, you still see everybody. But in that case, it's actually overlaying images, overlaying holograms onto what you see there. Problem is, you're going to be spending far more there. Microsoft HoloLens, for example, is about $3,000 right now. So couldn't quite afford that for this demo. Other things out there, you could do like the Z Space. That's more or less, they're tablets or large screens where it's kind of giving the virtual reality and just put on specs of some sort, and they give you that depth of view. But that works actually great if you're doing multiple people at the same time. Now, when it actually comes to what's running the VR, if you're doing phones and you're just going to do a 360 viewer, you're going to need something that has a gyroscope in it. It's not going to work without it. Most of the modern phones should have that, so you should be fine. Apple, iPhone 6 or up, Samsung, it says Galaxy S3 or up. I would actually recommend an S5 or later than that, preferably one that doesn't explode. For the LG, you could do the Nexus 5 and up, or you could do the Google Pixel, which works really well with the Daydream view. Now, when it actually comes to the computers, these are the specs that are actually listed by Oculus. It says you could use the GTX 970. I would recommend actually the 1070 or the 1080. Those are their brand new models out. And the nice thing about those models is there's no distinction now between laptop grade and desktop grade. It's just, here's the graphics card, put it in whatever machine you want. And for me, that's very important, because if you want to take your VR and actually go to a customer, you're not going to look around your desktop workstation. You want to bring a laptop with you. You're going to want an i5 or greater, probably an i7. You want plenty of RAM, HDMI port on there for the VR to actually be running for the headset. Now here it says you only need 2 USB 2.0 ports. I would say you actually need 4, and it's probably better if you have the 3.0 or 3.1. And the reason for that is the Oculus takes one of those ports, the sensor takes the other ports. To run my Leap Motion device takes another port, and to run my mouse takes another one. So I'm already up to 4. Software, Windows 7, Windows 10. Again, pretty much no support for Apple. Or you can just go out and buy a ready-made computer out there. You got Box, Dell, HP, Lenovo, and they're all here today too. But I'll talk a little bit specifically about mine. And full disclosure, Box actually helped me with this presentation by allowing me to use their laptop. It's a very powerful, very nice laptop. It's got the i7 in it, 32 gigabytes of DDR4 RAM. It's got the GTX 1080 in it, so it's pretty much the top of the line graphics card. And what I should mention is typically the GeForce GTX cards have been gaming cards, and they've been pushed as gaming cards, not professional workstation cards. However, it does run SolidWorks fine. It does run SolidWorks Visualize fine. So as long as you're not doing terribly large assemblies, you should be more than capable of running SolidWorks on this machine. It's got the 4 USB ports that you need, and it's got the HDMI port. Oops. All right, so for the software, we're going to focus on full VR. We're not going to worry about mobile for now. You're going to need Windows 7 or greater. Again, not much support for Apple. For your game engine, you can use the Unreal game engine. You can use a Unity game engine. Notice earlier in the presentation I said virtual reality is geared more towards gaming. Well, you're going to need a game engine to produce it. So I'm using Unity. It's a free software to go ahead and download. As long as you're not using it really for commercial purposes, you can use it all you want. For an SDK or a programming package, you're going to need like the Oculus SDK, Leap Motion SDK, whatever you're using to actually interact with your headset. And you're going to want like Visual Studio or something if you want to start customizing things. All right, so this is actually my workflow of bringing CAD models into virtual reality. It's actually relatively simple ever since SolidWorks Visualize came out. So first, have Unity installed or whatever game engine you're using. Go ahead and export your model to an OBJ or FBX format. Now, SolidWorks doesn't natively export to this format. So for the longest time, I had been using a community macro to do this. It's okay. It fails a little bit on some of the larger assemblies. It doesn't work terribly well. And the file size can be massive for this. You could have a 50 megabyte model end up being half a gigabyte or more in size once you convert it to OBJ. And that's just because it's tessellating the whole thing, giving you little tiny triangles for everything. So I prefer the method of actually using SolidWorks Visualize. I bring in the native model and I export out to FBX because it's a far smaller file size to deal with. So then after that, you'll go ahead and set up a Unity template. You'll import the file into Unity. Unity will go ahead and create it to a native asset there. And you'll take that asset right into your scene. If you got your character all set up, ready to go, then you can go ahead and run your VR. So here, I'll go ahead and actually show you more or less real time how you can do this. So I've just got a tutorial file pulled up here. So I'm going to take it and go ahead and just save it out as an assembly, as a part. It doesn't really matter. Visualize can pull in whatever model you're working with. So you just drag it and drop it. And with SolidWorks Visualize, if you're on Premium, you can actually get this for free. It's not the professional version, so you should be fine there. I'm actually using SolidWorks Visualize 2016 right now. So at this point, you go ahead, export it out as the FBX. And it's a fairly large file size from SolidWorks, but when you save it out to the FBX, it takes about 3 seconds to do, so it's not a big file size, not massive to deal with. Here I've got the Unity programming interface opened up. What I'm going to do is go ahead and just import that FBX model that I just exported. Go ahead and look for it. And this is about the biggest waiting time that you're going to have, is when it's actually taking the file and importing it. More or less because it's just converting it to a format that Unity can understand. But it doesn't take too long, just a few seconds for some of the smaller models. And then at that point, the asset's created. You can go ahead and just drag it onto your scene. And if you wanted to, start up your VR and take a look at it. Now, what I would recommend is while you can take your models straight from SolidWorks, throw them into Visualize, export it out, bring it in, remove the little bolts, remove the threads from your bolts, defeature it, make it a little bit smaller in size. You really don't need to see all that detail, unless you do in that case, just wait, because it does take time for it to convert back and forth. All right, so a few design tips and a few things that I ran into when I was getting this presentation ready. Motion sickness is something you really need to keep in mind with VR. It's very, very easy to get somebody sick. And I actually get motion sickness pretty easy, so I had to work with this for a while. So if you have close objects that are moving by quickly, or if you are flying through objects, flying through big structures, that's a good way to make somebody sick. If you start to move the camera without the user controlling it, more than likely you're going to make them sick right away. For that, what I mean is if I'm looking forward and all of a sudden my character in space turns 90 degrees, but I haven't moved my head, there's a disconnect between the senses there. So basically, yeah, virtual reality movement does not match the real world. It'll likely make you sick. So if you have a controller and you start to turn side to side, it makes you sick, and that's why I downgraded from using an Xbox controller just a Unity controller, or the Oculus Rift remote, because it's a whole lot easier. Or if you have slow hardware, if you have latency, or if you have missed frames, things of that nature, it starts to mess with the mind. And so more or less, nausea in VR is caused by the brain receiving two mixed signals. The eye see one thing in virtual reality, whereas your inner ear, your gyroscope for your body, doesn't sense movement, doesn't sense that change. And so when you get those mixed signals, the brain more or less interprets that as, I've been poisoned, I need to throw up now. Some possible solutions for this, if you are interested, teleportation, just move from one spot to another. It takes a little bit of that immersion out of it, but it's not too bad. It's good enough for the brain to figure out, oh, I'm in a new place, I'm fine. Upgrade your hardware, go visit Box if you can, maybe get a new laptop. But more or less make your camera movement predictable. If you want somebody to look somewhere, maybe if you have other avatars in there, have them look towards that place. Have there be a sound or a bright flash or something. Don't go ahead and move the character and make them look there. Let them do it natively. Or you could place the character in a capsule, like a spaceship, something like that. One of the things I was playing around with was to have a sphere actually around the head as you move. So it more or less blurs out the environment, but you have this static sphere. And so it pulls you a little bit out of the immersion, but enough so to where you don't get sick and you can move around and still see at least enough to know where you are. Pretty much no sideways movement at all. So no moving the character side to side unless the actual human is moving the head side to side, because there's just too much of a disconnect there between the motion. If that all fails, a little bit of ginger ale helps. All right, here's something I learned. I'm from the Midwest. I was developing this through the winter, working in the basement. It's kind of cold. If you're traveling somewhere where it is cold and you're going to show a client a VR demo, let the headset come up to temperature. Otherwise, you'll end up like this guy right here. You'll have the glasses fog up and everything, and it really takes the immersion out of it. All right, so talking about user control again, us engineers, we're not necessarily gamers, at least a lot of the engineers that I work with aren't. So you might want to reduce the number of inputs required. If I were to go ahead and hand this over to our senior engineer, I'm pretty sure he'd throw it right back at me. Versus you can use the simple remote, just forward, backwards, move it, ratchet side to side, and then just some main buttons like that. It really helps a lot, and if you're using Elite Motion where you can interact with your hands, that helps a lot. It makes it more fluid, more native. You don't really have to teach them the controls. They more or less pick it up, figure it out. All right. So I just wanted to show you a little bit more about what some other people are working on. Oops. Gotta actually press play here. So this company, what they do is they're actually trying to figure out a way to where you can design and build in virtual reality. Right now, they're kind of starting off slow. You have a pen along with your Oculus Rift, your headset, whatever you're using, and you can design simple squares. You can design circles, work kind of with simple rudimentary shapes right now. But a lot of technology we see starts off kind of small like this, and it eventually grows. So one day, maybe even somebody from Solidworks here might start to pitch this idea a little bit more. You could start to actually interact with your designs, redesign it, push it around, maybe even use your fingers to change dimensions, things of that nature. This one's kind of neat. One of my job functions at my work is to create configurators for our product lines. So that would involve basically a user being able to go through and say, I want this feature, I want this length, I want this, I want that. This company is working on it with cars. And what I've noticed a lot with VR is automakers are big pushers for it. They try and create that emotional experience for people. So in this case, you can sit in the car that you're looking to purchase. You can look around, get the feel for it. Go ahead and change the options if you want to. Say you want you want an automatic or you want a manual, you can change that. You want different colored seats, you can change that. So it's really a neat way to get people more immersed as opposed to going, all right, well, you want that option, let's go over and check this out. You want that, let's go over and check this out. It really gives more control back to the user to figure out what they want to do. I realized I had not shown you guys actually what I'm talking about. Let me go ahead and do that. All right. So yeah, the user can sit in the vehicle, they can look around, see what they want to do, get the information they need. So it doesn't really matter what your product is. And you could certainly do this in Unity if you wanted to. It's a free engine. It just takes time right now. For me, I have more time than I do money. Certainly, there are pre-made solutions out there where you could do things like this, but I obviously do not have a $10,000 budget to go out and do this, but I have plenty of spare hours on my hand. So you can go ahead and do all those different things and change things around as you want to. And then also, of course, NASA is doing stuff with VR. Why wouldn't they be? So this is actually a really neat demo. If you want to start to combine your virtual reality with your real-world applications, NASA's working on a way to where they can control robots with virtual reality and with a Kinect sensor. Certainly you could do other sensors here like the Leap Motion, but more or less they're taking a theoretical position of the hand and they're translating that over to the machine and telling it move to this position, move to that position, so they can control it remotely. So they want to take pretty much this concept and be able to control robots on the space station, control them wherever they are in the solar system, be able to control things, do different things of that nature. It really gives a way to, instead of spending all the time to program this machine, if you need to do something simple, but you can't put a human into that environment, perhaps it's too dangerous, this could be a way to go. All right, so just to let you know really quick, if you do want to see the demo, we've got it at 2 different places. Box was happy enough to showcase it in their booth number 629. And also the company I work for, we make 3D printers and we're showcasing it in our booth as well. So if you want to see it at any of those, please feel free to stop by. I've got the demo on my website for download. If you want the source code, please go ahead and contact me. I'd be more than happy to share it with you. Again, it's all stuff I learned on Google. It's stuff I learned off YouTube. There's nothing really proprietary about this stuff. So, questions? I know. I'm hoping it's there. Hopefully it'll come out maybe in 2018. Maybe we'll see it later on in the show. Maybe we can push them to get that, because that is something I would really like to do. For any of you who didn't hear, he was asking about, is there a way to do it directly out of SolidWorks, or perhaps they're really close to doing that. I honestly don't know. I haven't seen anything out there like that. Somebody may be working on an add-in to do just such a thing. There is one exhibitor here who you can take your SolidWorks model and they natively support it and bring it directly into VR, so it at least removes one step of having to convert the file, and also they have a pre-set up system. But it's far more expensive. You actually have to pay for the software there. All right, so the question was, how hard is it to get the Oculus Rift to work in Unity? They actually have pretty much universal support for the Oculus Rift, for the HTC Vive. I didn't really have to do any special programming in Unity. I went in and told it to add the VR asset, and then it supports the Oculus Rift, the HTC Vive, pretty much any headset that I want to do.
Any training, any videos that you recommend?
Google, YouTube. That's pretty much the way I figured it out. You pretty much just enter in, I want to make VR in Unity. That's pretty much how I started.
Did you visualize? Did you have to do all the colors and textures come across?
Most of them did, yes. The question was, for visualize, did I have to do anything special there to get the colors to come across? If you're using the colors and stuff in SolidWorks and you bring it into visualize, it'll keep your colors, it'll keep some of the textures, things of that nature. I haven't seen it work well with decals and things of that nature, so you would have to bring those into Unity separate and add them in as images. Sure. So the question is, what custom code did I do in Unity in order to get this demo working? I modified the base character so it could fly, so it could walk. Natively, it just walks around, but I wanted to be able to give that ability to fly, to run into walls, things of that nature. The one demo where we show our 3D printer, I made a little code in there to actually show the print appear on it. The demo where I show the small products, For that one, all I had to do was create it to where I would rotate through the different objects there. But however, the manipulation, all of that came out of Leap Motion, so they developed that already. A lot of these tools, you don't really need to do any development with. It's already out there. You just need to pick and place the code that you want into there and just debug whatever issues you might run into. Any other questions? All right, so that one was a little bit of work. I had to do basically look up a YouTube tutorial of how to add animation into Unity, and pretty much step by step, you click this, you add this slider, choose the length of the motion, and then it works that way. So again, all the tutorials out there exist on how to do all this. So when I say, his question was, why did I choose the Unity over Unreal Engine? And then also, what was the other one? Okay. So for the programming interface, the reason I chose Unity was more or less, I say I'm a self-taught programmer, I'm a self-taught Visual Basic programmer. Unity seemed to support Visual Basic a little bit better than the Unreal Engine. And the reason I'm using the Leap Motion controller as opposed to the Oculus Touch, which is Oculus's remote control system with the hand tracking and all of that, is the Leap Motion controller cost me about $50, and the Oculus Touch will cost me another $200. So, again, on a budget. Okay, so the question was, are any of the system requirements going to change? Oculus and HTC Vive, they've tried to put out there that these are the minimum specs. They'll be in place for quite a while. They won't change. As long as you can meet these minimum specs, you should be able to run VR in your system, whether it's this year, next year, or the year after that. But certainly if you can upgrade and get better machines, I would recommend doing that. I had this demo running on my workstation, which is a couple years old. Technically, it was not supported, but it did work, although it had a few frame rate issues. So certainly when I got the opportunity to use the box machine, I was more than happy to do it because for sure it could support the demo with no issues there. Any other questions? All right, well, thank you. Oh, question back there? Say that again? Yes. All right, for the Quadro cards, I'm not actually, I think it's the M6000 that you could use that supports it. I haven't really looked into the professional line of graphics cards too much, mostly just into the gaming ones because they're, again, on the lower end of cost-wise. So, all right, well, thank you guys for coming. Hopefully you guys try out VR.